Welcome, ladies and gentlemen, flerfs and flerfs. I'm looking at the Union Glacier Camp weather prediction because the final experiment is almost upon us. Sadly, I can't get the prediction for the 16th of December, but we are getting close. And I hope it will be sunny and the sun will cast a very long shadow which will scare away all the flerfs. And let's look at what will happen at the South Pole. Certainly not this. So, a while ago, MC2 asked me to create an animation for what happens at the South Pole with a gnomon and the shadow it is casting. But I misunderstood the assignment, so this was not the first thing I implemented. I implemented this one, which shows the prediction for the globe Earth on the South Pole. And as you can see, this sun takes a very different path from the flat Earth sun. And since I already implemented this version, I decided to make it into a sundial which will show the predicted shadow length and the altitude of the sun at Union Glacier Camp. For this, I had to download some secret NASA knowledge from the internet. So here it is. We need this file, this finance2008.all, which is coming from the International Earth Rotation Service. I didn't know we need a service for rotating the Earth, but here we go. We have this file with the latest predictions for the Earth's rotation, and also the other one is this file, which contains the ephemeris for the planet and sun and moon and other stellar objects. And with these files we can use the SkyField Python library, which is very easy to set up and very easy to make predictions for a given date. And let's first look at the result. So here is the sundial. As you can see, it's a lot of data, but let's go to it. So I had to wrap a table around an ellipse, so it's not an easy task, but let's hope I succeeded. So we have here the altitude of the sun, the cotangent of this altitude, and also the time in Chilean local summer time. On the bottom of the lines we have the azimuth of the shadow and the length of the shadow for a given gnomon height. And we have some assumptions which are wrong at the moment. As you can see, the time is, the weather is very different, but not so much. So I will recreate this sundial before MC2 takes it to the South Pole. But the assumption is that it will be minus 10 degrees Celsius, the pressure will be 980 millibar, and the gnomon will be 2 inches or 5.08 centimeters long. Alternatively, there could be a tripod set up with the height for the eye level, which is 165 centimeters, but since I given the cotangent value, it can be recalculated for any gnomon height. For 1 meter, it's easy, just use the cotangent value as the shadow length. Basically, this is it. The latitude and the longitude is fixed, and also the date is fixed, so this is not a universal sundial, it is for a specific date. It will work for the 15th and the 17th of the month also, but I designed it for the 16th because that's the middle date for the experiment. So let's put this sundial into our 3D simulation. As you can see, I could not model the sun at 96 million miles away, but it's very close. The shadow length is just barely under the line. Let's wait for a whole circle, and I show you the source code for this one. I promise it will not be complicated. It's just a simple Python. Let's look at the source code. As you can see, we need to import some things from the SkyField library and from math, and here are the basic data for this prediction. After we assign the variables for these values, we create a range for 24 hours, but we start from 3 hours UTC because the Chilean summer time is 3 hours behind UTC. This part is loading the secret NASA knowledge, the finals and the ephemeris files. Let's create a timescale from these values, and let's put ourselves into the correct latitude and longitude location, and also take into account the elevation, and we will also take into account the temperature and the pressure for the refraction calculations. But I promise we will not do any of these calculations ourselves because SkyField will do it for us. So after we calculated the altitude and azimuth values, we simply open a file and write our CSV into it. Let's take an empty file and run our script. The script is done, our file is ready, and let's look at a specific time which is of interest for the final experiment, and it is 5 hours 27 minutes, which is in UTC, but if you subtract 3 hours then you get Chilean time, 2 hours 27 minutes, and as you can see the sun is at 180 degrees azimuth, which means due south, and the shadow points due north at 0 degrees azimuth, and the shadow length for the tripod will be 7 meters and 5 centimeters. If you use a 1-inch gnomon, then the shadow length will be 4.27 inches. The code will be on GitHub. In the description you'll find the link. As you can see, predicting something for the globe Earth is not a very difficult task. Almost anyone can do it, maybe not flerfs.
If this happens to be the first video you ever watched on YouTube, allow me to tell you the rules. At the end of the video you must hit the subscribe, thumbs up, and bell buttons. You must leave a comment under the video. Farewell, until my next video.